Okay, here you see the purple pen pointing to the purple polymer practice sheet here. Nice alliteration. Um, let's work through a couple of problems making polymers from monomers. So the first thing we're going to look at is we're going to try to figure out is what's going on here with the monomer, and we see that there's one kind of monomer, so we're hoping that there's a nucleophile at one end and an electrophile at the other end, and that is true. We have the sodium hydroxide, which will deprotonate that, and so that'll make this into, put a negative charge there, and that will be our nucleophile. And then here we have the partial positive charge in the leaving group at the other end, so we have an electrophile. So these molecules, this nucleophile will react with the electrophile end of the next one, and etc., all the way down. And the best way, I think, unless you can easily picture these, is to draw out several of them. So I'm drawing out several of these molecules next to each other here. And you can pause the video and go ahead and do that on your own. Then as I do that, then I am reacting the nucleophilic end of one monomer with the electrophilic end of the other, and if I do that with a total of 3 molecules, then I'll get a trimer that results and make it easy to see the repeat unit in the polymer then. So here is a oxygen, which is going on to the next thing here. We have 1 carbon, 2 carbons, and then it's bonding to an oxygen, which is bonding to the next benzene ring. 1 carbon, 2 carbons, bonding to the oxygen, bonding to the next benzene ring. And so this is the trimer, and then we can put parentheses in the middle. It doesn't matter really where we start with our parentheses. We could start with the parentheses here, here, here. I typically like to start my parentheses where the actual molecule is starting. So I'm going to put a parenthesis around there, and then I'll put a parenthesis before we start a repeat of that molecule. And so then subscript N, and so if I'm drawing here the final answer, then I have a bond going through the parentheses, the oxygen bonding to the benzene ring, 1 carbon, 2 carbons, and then it's going on to the oxygen there, and subscript N. So here is the final polymer that is formed by this reacting with sodium hydroxide. So let's look at another one. Underneath we have an alkene at one end and an alcohol on the other end, and you'll recognize these reagents as if you had dumped in your mercury trifluoroacetate with an alcohol in the presence of an alkene. Then the alcohol would react with the alkene and form a bond. So let's first look at, imagine this as forming a polymer. We have a nucleophile on this end and an electrophile on that end, and we know that when the alcohol attacks this double bond, it's going to attack to the most branched position. And so here we have it attacking there and kicking up the electrons onto the other end, and here we are again attacking the most branched position. And just keep track of our carbons here, 1, 2, 3, 4, and then it's going to go on to the oxygen. Will be 1, 2, 3, 4, and onto the oxygen, and then we have this methyl, this carbon hanging off. And so let's put these together. 1, 2, 3, 4, going to an oxygen. 1, 2, 3, 4, going to an oxygen. 1, 2, 3, 4, and then this is the end of the chain here. So if we number these 1, 2, 3, 4, and this is carbon number 5, the one that's hanging off, that's not part of the main chain, then we have that there, and it picks up hydrogen, as you know it does in alkoxymercuration. And then same thing here, 1, 2, 3, 4, and here is carbon number 5 there, and then this end hasn't reacted. So we're looking here in the middle of the chain, and I am putting the parenthesis where this used to be the alkene right here, so I'm putting the parenthesis where the alcohol ends, and then here before the alcohol starts there, subscript N, and then we can draw the final product here in the spot where we have already where we have on the purple sheet here. And so oxygen 1, 2, 3, 4, and then going out the parentheses to the next thing, and we have the methyl group hanging off up there. So here is our polymer that we have formed in this reaction. The other thing that we need to consider is, well, what if it reacted with itself, what size ring would that form, and is that reasonable? So oxygen is number 1, 2, 3, 4, 5. It would form a 5-membered ring, and certainly it can do that. And so let's draw the product there. You can go ahead and pause the video and draw the product, and then turn it back on and see how you did. So I already determined that 1, 2, 3, 4, 5, it's a 5-membered ring with an oxygen in it, and so I am going to draw that. And I'm going to number the carbons, 1, 2, 3, 4, and so carbon 4 has carbon 5 hanging off, and so we have this as the other product. So here's the cyclic product, and here's the polymer product that forms there. And let's look at one more here, and we have strong base deprotonating our alcohol, and so we're going to have a minus charge there and a minus charge there, and then we have this diepoxide here, dielectrophile, and we know if we have this strongly basic conditions that it's going to be SN2, and that the reaction is going to happen in the least hindered position there, and that will pop the electrons in that bond up onto oxygen. So go ahead and pause the video and draw, figure out your products there. And again, what I would do is draw the diepoxide, the dialcohol, the diepoxide, the dialcohol. So so a total of 4 molecules, one of each, so you can see how it comes together. Okay, so I've drawn those out already, and you can show them reacting. And at this end, a nucleophile attacking the electrophile in the least hindered position, and then you will get a tetramer out of that. And let's start at this end. 1, 2, 3 carbons, and then the oxygen, which is bonding to this CH2, which no longer has an oxygen bonded to it, but this CH right here does have the oxygen bonded to it, and I'm going to put it like that, and then we go on to the CH2, onto the benzene ring, onto the next CH2, then we have a CH here, and that is still going to be bonded to the oxygen there, and then we're going on to this CH2 here, which is going to be bonded to by this oxygen here. 1, 2, 3, oxygen bonding to the CH2, bonding to the CH with an oxygen, etc. And then you can put parentheses around the 2 units that are making it repeat. And so if I want to start, I don't want to start at the end, but somewhere in the middle of this tetramer, I'm going to put parentheses here because this is where the epoxide used to be. And then I go through to the other end of the epoxide, and then I go all the way through the dialcohol molecule, and then this is when I would start the new, what used to be an epoxide there. So the parenthesis is there, and the subscript N is there, and so this is the repeat unit of the polymer. And if you get rid of this and get rid of this, leaving the bonds going through the parentheses, that's the standard representation of that polymer there. Okay, so we just worked through the first 3 here on the purple practice sheet, and there's, following that in your handout packet, there's even more polymer practice, and I guess on the back side of this there's more polymer practice. So more polymer practice, and then the yellow sheet after that in your packet, even more polymer practice. So you'll have plenty of opportunity to practice drawing polymers that form from a monomer. And one thing I want to point out before I end up here is that this could have formed a ring 2 theoretically, 1, 2, 3, 4, 5, 6, but the only problem is that the benzene ring in there is forcing the angle so that this is nowhere near that and could not possibly reach around there. And then this would form a huge ring, and that would not happen either. It's 3-membered ring to 6-membered ring.